Pluto, a distant and enigmatic dwarf planet, was once considered part of our solar system's planetary lineup. However, recent astonishing statements by prominent astrophysicists Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into the limelight with a startling claim. They propose that this icy body might be on a collision course with Neptune. But how could such a scenario unfold, and what would be the ramifications of such a colossal event? Are we on the brink of witnessing a rare astronomical occurrence, or is there something deeper at play in this looming cosmic collision? Join us as we delve into the possibilities of a Pluto-Neptune impact. Once classified as a planet but later demoted to a dwarf planet due to its unique orbit, Pluto continues to captivate the astronomical community. According to recent forecasts by leading scientists, Pluto's path is alarmingly close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both sounding the alarm over a potential hazardous collision between these two celestial bodies, which could pose a significant threat to Earth. How could such an event even be possible? Pluto's journey around the Sun is unlike any other in our solar system. Taking a staggering 248 years to complete a single orbit, since its discovery in 1930, it has yet to finish one full revolution. But the intrigue doesn't end there. Pluto's trajectory is marked by a highly elliptical shape, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its inclination, angled at 17 degrees to the ecliptic plane. The path Pluto traces is much steeper compared to the other planets, adding layers of complexity to its orbital dynamics. One of the most fascinating aspects of Pluto's orbit is its intersection with Neptune's path. For about 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune, defying expectations based on their positions in the solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers struggled to comprehend its unique trajectory. Unlike the other planets whose orbits lie relatively close to the ecliptic plane, Pluto's path stood out with its steep inclination and elliptical shape. The mystery deepened with the realization that Pluto's orbit actually crosses Neptune's. The stability of Pluto's orbit amidst these complexities is a testament to the intricacies of celestial mechanics. The three-body problem in space involves predicting how three objects, such as Pluto, Neptune, and the Sun, move and influence each other with their gravitational forces. It's like trying to determine their future positions based on where they start and how they pull on each other. In Pluto's case, this problem demonstrates how its path, Neptune's path, and the Sun's gravity all interact in a complex manner. Terms like apsidal libration and latitude libration, along with the VZK oscillation, are part of this puzzle. According to astrophysicists, what keeps all planets in their orbits is a phenomenon called apsidal libration. In the context of Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their paths from colliding. Latitude libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is situated significantly above their orbital plane, providing an additional layer of protection from potential collisions. Another vital component in this equation is the VZK oscillation, named after three scientists, von Zeipel, Lidov, and Kozai, who studied the motion of objects in space. It refers to how three celestial bodies, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pulling affects their movement, and in Pluto's case, the VZK oscillation helps explain why its orbit around the Sun is so unusual. Even though Pluto's path may seem erratic, this oscillation helps maintain its stability over long periods. The VZK oscillation demonstrates that even in the seemingly chaotic environment of space, certain patterns and rules help maintain order. All these factors contribute to keeping Pluto's orbit stable, preventing it from crashing into Neptune or being thrown off course. Understanding this three-body problem is crucial for grasping how these paths change due to the gravitational interactions between these celestial objects. Studying this helps us learn about Pluto, our solar system, and distant worlds and their stars. Numerical simulations conducted in the late 1980s revealed that despite these stable properties, Pluto's orbit is technically chaotic, with minor deviations in initial conditions leading to significant differences over millions of years. However, these unique characteristics of Pluto's orbit have been found to maintain stability over incredibly long timescales, effectively keeping chaos at bay. Recent computer simulations have furthered our understanding of how the giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a special resonance with Pluto, where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance helps keep Pluto's path steady, but Neptune isn't the only one contributing. Jupiter's gravity also plays a significant role in keeping Pluto's orbit safe and stable, with Saturn providing additional assistance. These simulations show that Jupiter's gravity alone is strong enough to ensure Pluto's stability for billions of years, demonstrating how Neptune, Jupiter, and Saturn work together to keep Pluto moving safely through space without encountering trouble. These phenomena are crucial in the context of the universe for maintaining the order and predictability of celestial movements. Without these mechanisms, our solar system would be a far more chaotic and unpredictable place. Bodies like Pluto could potentially collide with others or be ejected from their stable paths, leading to a domino effect on other celestial objects. Understanding Pluto's orbit, especially with the ongoing discussions about a potential collision with Neptune, is vital for gaining a clearer picture of the dynamic nature of our solar system. The case of Pluto illustrates how even the most seemingly unstable orbits can achieve equilibrium through the complex interplay of gravitational forces and orbital mechanics. It also underscores the importance of continuous observation and study of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the unpredictable nature of celestial bodies, and Pluto's orbit is a prime example of this unpredictability. The concept of orbital chaos, which refers to the sensitive dependence of a celestial body's path on its initial conditions, is vividly illustrated in Pluto's case. This means that even slight variations in Pluto's position or velocity can significantly alter its long-term trajectory. Pluto, a distant and mysterious dwarf planet, was once part of our solar system's planetary family. However, recent startling announcements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a shocking revelation. They suggest that this icy world is on a potential collision course with Neptune. But how could this happen, and what would be the consequences of such a massive event? Are we witnessing a rare astronomical phenomenon, or is there something more to this impending cosmic collision? Join us as we explore the possibilities of a Pluto-Neptune impact. Pluto, a former planet that was demoted to a dwarf planet partly due to its peculiar orbit, remains a subject of fascination and study in the astronomical community. According to recent predictions by leading scientists, Pluto's trajectory is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the red flag of a possible hazardous collision between these two planets that could pose a huge threat to Earth. How is such an event even possible? Pluto's journey around the Sun is unlike any other planet in our solar system. It takes a staggering 248 years to complete a single orbit, meaning that since its discovery in 1930, it hasn't even finished one full revolution. But the intrigue doesn't stop there. Pluto's path is marked by its highly elliptical shape, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more peculiar is its inclination, angled at 17 degrees to the ecliptic plane. The path Pluto traces is much steeper compared to the other planets. This inclination and elliptical nature add layers of complexity to its orbital pattern. One of the most intriguing aspects of Pluto's orbit is its intersection with Neptune's path. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect based on their positions in the solar system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets.